Where are things held? All right, objects live out here on the heap. So when I've been drawing this, I actually have been drawing a stack and a heap. I just haven't been very specific about it. Here's the stack. Here's the heap. Objects live over here on the heap. Okay? They have, let's say, Mrs. Keats. We'll make that the name of the account, and we'll say that it has, I don't know, $100 in it. A234. The reference is going to be here, so maybe it says at bank account, blah, 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 blah. Okay, that's on the stack. The object lives on the heap, as do its instance variables, so its state is living out there too. Let's say I called something deposit on it, and I said, I want to deposit another $100. Okay, this lives on the stack, and so does the data that's with it. All right, so once this method is completed, it pops off the stack. So it's like, oh, I ran deposit 100. I don't need this information anymore. It pops off the stack. Actually, you know what? We'll go like this. It pops off the stack here. This is erased because we don't need it anymore. And the memory is used up. Okay, so it makes space for whatever else we need to run the program. That way, it's using efficient use of space. However, Mrs. Keat here, let's say, well, we didn't do that fully correctly. Let's say deposit 100. Okay, what happens? So I've created Mrs. Keat, and then I have added 100 to the balance. Now that this is done, this is gone, hops off of the stack, we get rid of the whole thing so that new memory can be used, or you can recycle the memory. So I talked about this a little bit. I introduced this term of scope. It's really important. What is the scope? Where, or not where, but how long does a variable live? All right. Instance variables have a class scope. They live everywhere here. Now, I showed you that really quickly by saying my balance. If I use my balance, or you can see it actually anywhere. I used my balance, my account number. I used that all the way through the class. And that's because it has a class scope, so I can use it anywhere inside of here. It begins here at the first curly brace and ends here at the last one. Okay? The methods can access the instance variables. They can change them. They can do whatever they need. They can get information from them. They live on the heap. So as long as the object is alive, so is its state. Now, a local variable like like amount here only lives inside the curly braces in which it is defined, or like right before it's defined. So inside, when we used for loops, let's see, for int I becomes 0, I is less than 3, I plus plus. It doesn't like this because it's not within a method, so let's just, and then we'll say, I don't know, system.out.println I. I'm just going to make a method for this, so it public int print I. So this is another case of a local variable. Here we have amount, but we also have I. If I try and access I, I'll say plus equals 7. If I try and access I outside of my loop, it doesn't work because I only lives inside these curly braces. As soon as we're out of there, I is dead. That's why when we use a count, we have to initialize that count before we go through the loop. Otherwise, it can't be accessed outside of the loop. Okay? Same thing with amount. It's defined here or declared here. It's only going to last inside of here. I'm going to get rid of this. This is just a little teaching tool. A local variable was like I that I just showed you. This one is also considered a local variable, but we can also call it a parameter variable. It can last the entire method. So if there was a for loop inside here, it could go inside the for loop, but it can't go outside of the for. It doesn't live outside. All right. So when we talk about comments, there are two types of comments. We have already talked about this. This one is more than one line. This one is just one line. We also talked about Java.comments. I mentioned them. I said, you should get used to like looking at them, but you don't need to actually use them. They create our APIs where we go for like our string and our math class. So we have one that's going to give us the author. These are notations that we can use to make that HTML or that web page that's going to show us a nice organized way to see our class and everything that it does. So the summary, the return, the version, it's going to give us a bunch of information. That's important, but most important, because you will see this over and over again on the AP and just in general, like you have to remember that when you're coding in the real world, you're not going to be coding something all on your own. You're going to be on a team, and part of your code is going to go into somebody else's code, and someone else may use it. So you need to be very specific about about using and also reading other people's comments. And the biggest thing are the preconditions and the postconditions. So what are the preconditions? The preconditions are things that must be true in order for the method to run. Okay? When we write methods, we can assume that these are true. Postconditions are things that have to be true after the method is run. So this is like something that we actually have to make sure that our method is doing. We have to be sure to fulfill these when we write the method. Otherwise, we're not following what the preconditions and the postconditions are. So these are kind of like pacts that you're making with the other coder. The pact here is that you're saying, all right, well, these things must be true in order to get into my method and use my method, and this is what my method actually does. I wanted to take a look real quick. So I wanted to be specific and show you kind of an example of where these are, these preconditions and these postconditions. In this, we use this in our study session. This was string manip. I believe that was the name of the class. So you can see that there's a precondition right here. str contains only lowercase letters and spaces. So they're telling you, you can assume that this parameter that you're receiving is only going to get lowercase letters and spaces. You don't need to worry about anything that is capitalized or digits or anything like that. You're only going to get lowercase letters and spaces. So that's a precondition. So that's something, a pact that somebody has made with you. Now it could say postcondition. This will have a print statement that will print out whether str is a palindrome or not. That could be a postcondition that they use. So as we move along, we have talked about static fields. We haven't really talked about, and static methods actually, because we use the math class. They hold variables that are shared by all objects of the class. We talked about it, like if we don't need to create a class in the case of the math, or an object in the case of the math class, because we don't need, like, nothing specific needs to be done. We just need to use things. But let's talk about, like, in case of a bank account. Let's assume that this is a bank account for a specific bank. Well, all banks have a routing number. So maybe we would say public, and I'm going to make this final because I don't want anyone to change it. And then maybe I'll say the static goes right here. Public static int. Oh, public static final int routing number. Okay. And so, I don't need parentheses. So what that's going to do is, I believe that I Oh, it's telling me I haven't initialized it, which is fine. Like, it wants me to initialize it to begin with because it's final. So let me just initialize that to, let's pretend that it's 711564. Okay? That means everybody at this specific bank will have that routing number. So, usually you can find them on checks, or like sometimes if you do direct deposit and stuff, you need to know the routing number for a bank. And so, but everybody's routing number is the same because it's kind of like the ID number for the bank, right? It's something that everybody who is in that bank, all bank accounts own that. They all have the same routing number. And we wanted to make it final because we don't want anyone to change it. But it's something that we could have public because maybe we want people to be able to access it. Oh, I should put this, since it's final, in caps. Routing. No. Oh. There we go. All right, non-static fields, and these ones, my balance or my account number, they're very specific to the object. So static ones are owned by the entire class, and non-static ones are, they're not, they're owned by the specific object. There's separate memory location for these static fields, okay? Some of them are final. In this case, I made this one final. Some of them, they may vary. So in the case of like any kind of team, the static field would be the score because, or not team, I should say. Let's say it was like a soccer player and a soccer player belongs to the team. Any type of team score would be owned by the entire team, and it would change depending on whether or not people scored. All right, and they can be accessed by all methods because let's say I'm a basketball player and I score, and maybe I want to update my score, like my own personal score, and I want to update the team score. So I want to be able to do that in both accounts. But not everybody is going to score at the same time. Only one player is. So I want to call that on an object. Like maybe I want to say, I don't know, Michael Jordan dot score. Michael Jordan is the object. He's specifically going to score, but then the Bulls would actually also, their team score would go up. Static methods, on the other hand, they're very specific. They belong to the class. We've used them like in the math class. They're not specific to any object, okay? And it's only to access and change static fields. They do not have access to non-static methods. Okay? They only have access to static methods. I'm sorry. They do not have access to, well, they only have access to things that are static. So they only have access to static fields, static data, like this. And they only have access to other static methods. They cannot do anything that's non-static. Okay? How do we call them? Actually, I think I want to talk about it real quick. What is the scope of a static method? So the scope of a static method, because it is owned by the entire class, it's going to be alive as long as at least one of the objects is alive from that class. So as soon as one is created from the class, now that static variable is alive, and then until the last one is living, it will still be alive as well. So how do we call the methods? We've talked about this before, but I wanted to review this. All right, we use math.pal. This is static, all right, because we're calling it on the class. Billy.smile, this is non-static because we're calling it on the object, okay? And then there's this keyword this that we're talking about. We'll talk about that in a minute. All right, so when we call a static method, okay, we have to call it on the class. Here's an example. If we're outside of the class, if we're inside of the class itself, we can just use the method name. And that goes for any of the methods. If we're inside the class itself, so if I'm inside this bank account method, I can call withdraw or get my account number or deposit or the other deposit at any time without putting an object in front of it. Because once I'm inside the class, it's no big deal. Okay, and I wouldn't really use an object name because I'm not going to create an object inside my class. When I call a non-static method, I'm going to call it on an object if I'm outside of the class. So I should be specific. If I'm calling a static method, if I'm outside of the class, I'm going to call it on the class. Okay? If I'm inside of the class, I don't need that. I can just call it by its method name. For a non-static method, if I'm outside of the class, I have to call it on an object. If I'm inside of the class, I can call it on this dot smile or smile. Okay, without anything in front of it, without an object in front of it. Same thing for a field. Okay, if I'm outside of the class, I have to call it on the class itself. If I'm inside of the class, I can just refer to it by its name. If I'm outside of the class for a non-static field, I have to call it on an object. If I'm inside of the class, I can just use its own keyword name. I shouldn't say keyword. Its own name, which in this case is my name, or I can call it on the keyword this. Okay. So where can I access something? Because this is getting a little confusing, right? All methods have access to only public methods and constructors belonging to other classes. So you can't use anything unless it's public outside of the class. Non-static methods have access to all public or private methods or constructors and data of its own class. All static methods have access to all public or private static methods and static data of its own class. So non-static can access both static and non-static, but static methods can only deal with static things.